Vanakkam. Welcome to this course on classics in neuroscience. In the last few lectures, we have been looking at classic Nobel Prize winning works. In this series of videos, we are looking at the classic Nobel Prize winning works of Robert Barany. His work led to an improved understanding of brain's balance system, and he explained vertigo and dizziness and the ear-brain connections. Went on to win the 1914 Nobel Prize in Physiology or Medicine. In this video, in today's class, we will look at the serendipitous discovery of the caloric test by Robert Barany and the details that led to his development of the caloric test and the detailed protocol that he used, the details of the test and the protocol that he used to study the inner ear and the balance dysfunctions, and the simple elegant method that he developed for studying this. What Barany found while working with patients who complained of vertigo, that if you pour water inside the inner ear, he found that the direction of the nystagmus, the eye movement, the direction of that eye movement was different depending on the temperature of the water poured. Recall that there are two sets of semicircular canals, one in the right ear, one in the left ear, two sets. It's possible for one of them to be healthy, the other one to have some dysfunction. So, you could technically perform two sets of tests on the same patient with differing temperatures of water and show that in the case that is affected, on the side that is affected, there is a dysfunction, whereas the same temperature of water did not show the same type of dysfunction in the other side in the same patient. In this case, the patient becomes his or her own control and serves as an excellent experimental model for studying this. And this, of course, only if the dysfunction is on one side, but you could choose patients who have this problem. So, Barany, by testing this with water at different temperatures, so he essentially irrigated the inner ear with water at different temperatures, and he recorded the direction of nystagmus, and he concluded that the temperature of water was responsible, had a causal role in the direction of nystagmus, which was a brilliant insight for that age. The temperature of water had a causal role in the direction of nystagmus, establishing that somehow this temperature caused some sensation that caused the nystagmus. Earlier it was known, we saw in the previous video, that the semicircular canal was responsible for the sense of balance, the sense of rotation, the sense of the turning sensation. This was already established now. But that was more like, if I remove this part, people lose this effect, people lose this faculty, ability. That's fine, but exactly how this works was not known. What is the physiology behind this? How does the semicircular canal actually detect this was not known. So, he observed that pouring cold or warm water causes involuntary eye movements and dizziness, and he explained that the change in the temperature caused the endolymph to move in certain directions. In other words, there is a convective change. Temperature change of the inner ear causes a convective change in the endolymph within the semicircular canal, leading to an increased sensitivity to motion, leading to an increased sensitivity and motion of the hair cells that were responsible for detection of this movement. Because of this increased sensitivity, these sensory neurons that are located within the semicircular canal detected motion that did not exist, leading to a sensory dissonance between what they see and what is that they are feeling. Remember, this will be a very intense feeling. It will be an intense experience, because what they are seeing is that the room is not rotating or otherwise moving, or I am not moving with reference to the room. But what they are feeling inside the inner ear is a product of millions of years of evolution. There is sensory weighting such that this is the only sense that can detect the rotational motion, but your eye is telling that there is no rotational motion, but your inner ear is telling that there is a rotational motion. Actually, there is no rotational motion, but because of the convective change because of the increase in temperature, there is convection that happens that moves the endolymph within the semicircular canal, making these sensors, making these sensory neurons to wrongly perceive rotational motion when it does not exist. This sensory dissonance leads to an intense experience of vertigo, dizziness, sometimes nausea, vomiting, all these things. So this affects the brain's perception of motion and balance, leading to this nystagmus. In particular, if you irrigate the same ear with a colder temperature water, then what you will observe is that nystagmus is in the opposite direction, showing that the direction of motion is causally related to the temperature of water. So, if you use warm water that is above 44 degrees Celsius, nystagmus happens in one direction. If you use cold water, water that is below 30 degrees Celsius, nystagmus happens in the opposite direction. If there is no sensitivity or response to the temperature of water, that means that the inner ear has some serious vestibular dysfunction. Of course, room temperature water or body temperature water, human body temperature water, if you irrigate the inner ear with the water at a temperature that is the same as the healthy human body temperature, then you will find no nystagmus, but that is not surprising. So, colder water produces nystagmus in a particular direction, warm water produces nystagmus in a different direction. Note that the water cannot be very warm, above 50 degrees Celsius can be damaging. So, just above 44 degrees Celsius is what we use, of course, that is common sense. So, Barany continued to extend this work on equilibrium and the vestibular system, and he established that the semicircular canal indeed detect rotational movement, and they do so by movement of these sensory neurons that are located within the semicircular canals, and these sensory neurons may be wrongly activated by increasing the temperature of the inner ear, that leads to an increase of temperature of the fluid that is moving within the inner ear, the endolymph that is moving within the inner ear. He created the Barany chair, a device that is used to study the effect of rotating a patient and the vestibular function. Later, after winning the Nobel Prize, he continued this line of study and studied benign paroxysmal positional vertigo, the vertigo that is the most common form, BPPV, or benign paroxysmal positional vertigo, and essentially laid the groundwork for modern treatments for BPPV. What is a modern treatment for BPPV? It is called Epley's maneuver. Not really relevant to the lecture on Barany, but those who are interested can Google this and learn about what is Epley's maneuver. It's a simple maneuver. It's not actually a invasive procedure. Recall that the procedure used by Barany is also not a invasive, well, technically pouring water is not really an invasive procedure. So, his work essentially laid the foundation for diagnosing dizziness, vertigo and inner ear disorders. So, this test demonstrated the changes in the temperature, how it affects the movement of the endolymph, and the changes in a causal way, in a one-to-one manner, the change of perception of balance. The direction of eye movements depended on whether the temperature was warm or cold. This is a simple, elegant clinical test to diagnose inner ear disorders. This is still being used as the Barany test or the caloric reflexive test. It showed how inner ear sends signals to the brain about movement and balance, about whether there is any rotation that is happening, thus improving our understanding of vertigo, motion sickness and dizziness and rotational and turning movement, and a disability that comes in that happens because of this dysfunction. So, if there is no semicircular canal, there was no nystagmus that was shown. If you irrigate the inner ear with cold water, the nystagmus is in a particular direction. See, this is the direction of nystagmus that is shown, and the same inner ear, if you irrigate with warm water, the nystagmus is in the opposite direction, thus conclusively providing evidence for how the semicircular canal detected this rotational motion. It is not that Robert Barany discovered that semicircular canals are responsible for detecting rotational motion or turning motion. No, but before Robert Barany's studies, it was not known how did they do it. Everybody knew that the semicircular canals are somehow responsible for detecting rotational movements, but how did they achieve that? Now there was evidence to show that this was because the semicircular canal had sensory neurons that responded to motion in certain directions, and these direction of motion can be indirectly influenced by the temperature, because that temperature, remember that semicircular canal is a sealed package. So, when you irrigate the water, you are not directly irrigating the inner ear or the semicircular canal, you are essentially irrigating the inner ear, but not the semicircular canal. That is a sealed package. So, what is happening is convection that is happening. Due to that convection, the temperature of the endolymph, the liquid inside, changes, thus changing the direction of sensation. So, thus establishing a critical, crucial physiological fact. Before that, it was known that semicircular canals somehow do this. Now we know how they do this. That was the major critical contribution of Robert Barany and his caloric test. Note that his test is still being used in the study of inner ear and study of dizziness, balance, posture and vertigo. Even today, this test is the first cut test. And there are other tests nowadays that are available with modern technology, but this is still the test that is performed by physicians. A simple test. You really do not need any equipment, no need of any biomedical instrument other than the modest syringe, the cheap affordable syringe and warm water, that is approximately that. So, in summary, in this video we looked at the serendipitous discovery of the caloric test. Of course, just by one experiment he did not come to this conclusion. He repeated this on hundreds of patients and then he documented that evidence. Obviously, being a rigorous experimentalist helped, and we also looked at the details of the test and the specific protocol that he used and how his work conclusively showed the connection between the temperature of the water that was used and the direction of the nystagmus, essentially establishing the manner in which, the method in which the semicircular canal detected the direction of motion. With this, we come to the end of this video. Thank you very much for your attention.